So a system of equations with three variables is going to introduce a third variable, which most commonly is just z, so x, y, and z. So when graphing, you guys are used to looking at a piece of paper, and you guys will graph the x and y. This is the x, the one that goes up is the y, the vertical one. So this third axis would really, to make it 3D, it would essentially be coming out of your paper is what would happen. Now, it's a little hard to comprehend, I understand that, but that's essentially what it means. So the solution to a system with three variables means it has an ordered pair with three values, x, y, and z. Now, there are some pictures below. I did post a picture in the page where you found this video. I'm hoping it might clear it up a little bit for you guys. But if you guys have exactly one section, so the green, so let's say the green is your x-plane. Your blue is the y plane, going back to geometry here. And what do we have left? The red would be your z plane. Remember, a plane is a flat surface going infinity out in every direction. It's just a flat surface. So, in order for you to have an ordered triple pair, or an ordered triple, if you have exactly one solution, that means that your three planes intersect at exactly one point. So if you look at this first picture, the green, red, and blue plane all intersect at that one point. That one point is the solution for whatever system that was. So infinitely many solutions, again, you have the blue, green, and red plane all intersecting each other. Well, they're intersecting right in the middle, and that middle is made up of multiple points there. So that is a line, and remember, lines are made up of an infinitely many number of points. So in that case, that's why you have an infinite number of solutions, because they don't just intersect at a single point, they're intersecting at a line which has multiple values there. Infinitely many values, to be exact. So when you have no solution, it means that the planes have no common point of intersection. So do your planes, two planes intersect? Yes, they're the blue and green, green and red, blue and red, but nowhere do the green, blue, and red all intersect each other. Same with this one, that one, there's absolutely no solution for any two of the variables. So the only time you have a solution for a system with three variables is if you have all three values intersecting each other. So the elimination method for a three variable system, we call this double elimination. The double elimination method. So there's multiple steps. It takes me about 5 steps, essentially, and you'll see once I do an example with you to get through the double elimination process. But step 1 is to rewrite your linear system in 3 variables as a linear system in 2 variables using the elimination method, and you will need to do it one more time so that you can do it for 2 equations. So you're doing it double elimination. So you will solve those 2 equations that you now have, that new linear system, for both of its variables. once you solve, so that's a normal system of equations like you guys have done in the past, you're going to substitute the values you found in step 2, so those variables you just found, into one of the original equations and solve for the remaining variables. So you'll end up creating 2 regular systems of equations, eliminating one of the 3 variables, so you only have 2 to solve for. Solve for those 2 variables, then you'll plug both of them back into one of the original equations to solve for that 3rd variable that you originally eliminated. So just like anything else, if you obtain a false solution such as 0 equals 1, then the system has no solution. Or just like normal, if you create an identity such as 0 equals 0, or 6 equals 6, or 5 equals 5, or negative 10 equals negative 10, then your system has infinitely many solutions. So let's go ahead and try this double elimination method if you guys want to flip your page over. Now I'm making a screencast and I'm going to try to make this as neat and as organized as possible. So the first thing I want to do is I'm looking at my 3 equations and you're going to figure out which variable do I want to eliminate for the first step, which is creating 2 equations with just 2 variables. So I'm looking at this and I'm thinking the easiest one, I'm either going to eliminate x or y, and the reason I say that is because they both have a coefficient of 1. So usually that's the one I will eliminate. So in this case, I will eliminate the x. So you can eliminate the x by using any 2 of the 3 equations you like. So if I multiply that first equation by negative 2, what will happen is that will become negative 2x minus 4y plus 6z equals positive 6. And I said I'm going to use the second equation to eliminate that x, so just write that right underneath. So 2x minus 5y plus 4z equals 13. So now you guys can just add them up. Your x's will eliminate. That's the goal at hand here. Negative 4 plus negative 5. So you have negative 9y plus 10z equals 19. So now let's go back to the 3 equations. So right now we have done elimination once to get 1 equation with 2 variables. We need to go back up now to our 3 equations and say, okay, what's another way we could eliminate the x? Remember, you don't want to use elimination once and eliminate an x, and then use it again and eliminate a y or a z. You want to eliminate the same variable twice. So you guys are more than allowed to use the same equation, and I'm going to. So this time I'm going to multiply that same equation, but this time by negative 5, and then I'm going to use the 3rd equation to eliminate the x. So I'm just writing my steps in order here, so if you go back and look, you'll know which came first. So multiply that negative 5 through there, so negative 5x minus 10y plus 15z equals negative 5 times negative 3, which will give us positive 15. And just rewrite that equation that we're using to eliminate it. So that 3rd equation, 5x plus 4y minus z equals 5. So here our x's will eliminate. Negative 10 plus 4 is negative 6y. 15 minus 1 is 14z. And 15 plus 5 is 20. So, now we've used elimination twice, double elimination, to get two equations with two variables. Now it's just like everything we've ever done since Algebra 1. Solve a system of equations with two variables. So, I'm going to write both of those equations that I have just now worked for to get. So, negative 6y plus 14z equals 20. And negative 9y plus 10z equals 19. So there's no real easy way here to get 14 to 10, 10 to 14, or 6 to 9, and 9 to 6. So we just have to figure out a common multiple of those two numbers. So I'm going to get them both to 18. 18 for my x's is a common multiple for 9 and 6. So I'm going to multiply the first one by negative 3 to make that positive 18. And just multiply the second equation by 2. And that will stay negative, but it will now become 18. So this will now be 18y minus 42z equals negative 60. And then negative 18y plus 20z equals 38. So add them up. Y's eliminate. Negative 42 and 20 gives us negative 22z equals negative 60 and negative 38 is negative 22. So divide by negative 22 on both sides, and you get z equals 1. So now you guys can go ahead and plug that z value into either one of the two equations that you solved for. So I am going to plug it into that first one. So negative 9 times y, which is what we're solving for, plus 10 times 1 equals 19. So 10 times 1 is 10. So negative 9y. Subtract the 10 over. So 19 minus 10 will give you 9. Divide by negative 9 on both sides. Y will be negative 1. So we have our y, our z. The last thing we need to do now is solve for our x. So the last step will be plug in the two variables you have to find the third, one of the original equations. So we'll just plug it into the very first one. So x plus 2y minus 3z. So x is what we're trying to find, plus 2 times y, which is negative 1, minus 3 times z, which is 1, equals negative 3. So x minus 2 minus 3 equals negative 3. So x minus 5 equals negative 3. Add the 5 over. X equals 2. So your final solution here is the ordered triple. Sounds weird to say, but 2, negative 1, 1. So, like I said, 5 steps for me is what it usually takes. It may take you more or less. Just make sure you guys keep your work ordered and organized as always, and you should be okay. But let's try the second one on this page. And I might go through it a little quicker this time since it's not our first one. number 2, 3 equations, 3 variables. First thing we need to do is figure out which one we want to eliminate. In this case, I'm probably going to eliminate the y because that's the only one with a coefficient of 1. So I'm going to multiply this equation first by 2 to use that first equation to eliminate it. So if I do that, so step 1, 2 times 2x gives me 4x minus 2y plus 6z equals 8. And we're just going to use that first equation, 3x plus 2y plus 4z equals 11, to eliminate those y's. So combine them and you guys get 7x, y's eliminate. 6 plus 4 is 10z equals 88. First elimination done. Second one, I'm going to use that same equation again, but this time I'm going to multiply it by -3 so that it becomes positive 3y to eliminate with that negative 3y in the third equation. So negative 3 times that whole middle equation, so negative 6x plus 3y minus 9z equals negative 12. And we're going to use that third equation, 5x minus 3y plus 5z equals negative 1 to eliminate the y's there. So, 2 equations, 2 variables, put them together to solve for one of them. So that's our third step. And I just realized that I multiplied 8 and 11 times added instead of adding 8 and 11, so this is not 88. This should be 19. So with that fixed, let's continue on. So 7x plus 10z equals 19. And negative x minus 4z equals negative 13. So, easiest one here to eliminate would probably be the x to solve for the z. So if we multiply this times 7, this will become negative 7x minus 28z equals 13 times 7, which is 91. Negative 91. So that means that equation is essentially gone, and we can add the top one with this new one. So the x's cancel. 10 minus 28 gives us negative 18z equals 19 plus negative 91 equals negative 72. Divide them both sides by negative 18 and get z equals 4. So now we need to plug z into one of the 2 equations that we solved for 2 variables. So let's just plug it into that second one. So negative x minus 4 times 4, which we found to be z, equals negative 13. So negative 6 minus 16 equals negative 13. Add the 16 over, get negative x equals 3. So positive x will equal negative 3. So let me rearrange and get some more space here, and then that last step will be to just choose one of the third equations to plug x and z into to solve for y. So, number 5. So let's just plug it into that bottom one. So 5 times x, which is -3, minus 3 times y, which we're solving for, plus 5 times z, which is 4, equals -1. So -15 minus 3y plus 20 equals -1. So -15 plus 20 is 5. So if we subtract the 5 over, we get -3y equals -6. Divide by -3. And y is 2. So our ordered pair here, or ordered triple, even I have trouble forgetting that it's called an ordered triple, is going to be in order x, y, z. So -3, 2, 4. Solve for two equations with two variables. Solve that system. Get the solution for one of your variables. Plug it back in to get your second. And then you'll have two of the three that you can solve back or plug back into one of the original 3 equations to get that third variable. We'll try one more together here. For number 3, it asks you guys to find the standard form of the equation of a parabola, because that's a quadratic, that goes through the given points -3, 10, -1, 0, and 2, 15. So all it gives us are all the x and y values, or some x and y values, that are included in this, or on this parabola. So if we know that the standard form of a quadratic equation is y equals ax squared plus bx plus c, we only have the y and the x values. We're missing the a, b, and c to be able to write this equation. So what's going to happen is x, y, and z aren't going to be the 3 variables we're solving for. We're going to be solving for a, b, and c so that we can write an equation. So the first thing we need is a system of equations. So if you know all these x and y values, you're going to use those 3 points to create 3 equations. So your first equation will be y equals, so 10 equals a times -3 squared plus b times x, which is -3, plus c. The second equation will be 0 equals a times -1 squared plus b times -1 plus c. And your last one will be 15 equals a times 2 squared plus b times 2 plus c. So these 3 equations, I think I've said equations too many times, it's starting to sound funny, but these 3 equations will become 10 equals 9a minus 3b plus c. 0 equals 1a minus 1b plus c. And 15 equals 4a plus 2b plus c. So this becomes your system of 3 equations. So we have to do the same process that we did with the last two as far as using double elimination to get two equations with two variables so that we can solve for our first variable. So I'm going to go ahead and multiply this first equation, or this middle equation, by -3 to use that first equation. So I'm going to eliminate the b's. So this will become -3 times 0 is still just 0 equals -3a now plus 3b minus 3c. Combine it with that first equation, 10 equals 9a minus 3b plus c. So we'll get 10 equals 6a, b's eliminate, minus 2c. Alright, let's see here. I can, again, use that same equation. And this time, I'm going to multiply it by negative, or just 2, sorry, to eliminate with this equation. So 2, we'll get 0 equals 2a minus 2b plus 2c. Combine it with that last equation, 15 equals 4a plus 2b plus c. 15 plus 0 is 15, 4 plus 2 is 6a, b's eliminate, 2 plus 1 is 3c. So we have to use those two equations. To now do regular elimination, so to solve for A or C. So write them both together. So 10 equals 6A minus 2C, and 15 equals 6A plus 3C. So this one's really easy. All I'm going to do is multiply that first equation by a negative. So that will make this -10 equals -6a plus 2c, and that one is now gone. So we'll just work with the space that we have. So -10 plus 15 gives us 5. A's will eliminate. 3 plus 2 gives us 5c. Divide by 5. C is 1. I know you guys have the entire page to work with, so if you're feeling comfortable, continue on. I just need to get some more space here to work with, so give me a second. So I just brought the previous page over and shrunk it down a little bit to give me more room. So, continuing on. So now that we have C, again, we can substitute it into either one of these two equations that you guys solved for. So I'm going to plug it into that first one. So 10 equals 6 times A, which we're solving for, minus 2 times C, which is 1. So 10 equals 6A minus 2, add the 2. 12 equals 6A, divide by 6, and A is 2. Last step, now that we have 2 of our 3 variables, is solve for all 3. So go back to our original equations, which were right here, and pick one of them to plug your 2 variables into. So I'm just going to pick the one with a 0 in it, and all the 1s. Seems the easiest. So 0 equals, and this is our fifth step, 1 times a, which is 2, minus 1 times b, which we're trying to find, plus c, which is 1. So 0 equals 2 minus b plus 1. So 3 minus b, subtract the 3. B is negative 3. So it's not asking us for a tripled order here. It's not asking us for an intersection point. It's saying, okay, we have a parabola here. What are the values of a, b, and c so that we can write an equation? So our equation, remember, in standard form is y equals ax squared plus bx plus c will be y equals a, which is 2, so 2x squared, plus b, so minus 3x, plus c, which is 1. And that's all there is to it. Like I said, you guys have an entire page, so just make sure, so you guys should have been able to keep it a little more organized than I could, but if you got confused with anything that I did, just let me know. And you guys have 5 to do for homework or for practice. So just let me know if you guys get stuck. I know this is very new to you.